the reason why these trig derivatives are so important, okay? So, first of all, this is a new day, so I'm going to say this is example 1, okay? Can we all see that? Should I zoom in a little bit? I know. It's going. It's thinking, okay? So here's example 1. Let's say the function of y is equal to x minus tangent x, okay? Now, if I want to find the derivative, well, it's easy to understand. The derivative of x is what? Is 1, right? Now, the derivative of tangent x, like I said, we could go through and prove all of this, okay? But if we have this memorized, what are we allowed to do with the derivative of tangent x? Just call it secant. Secant squared, exactly. So just negative secant squared. Oops, make sure that says y prime. Yeah. Okay, he was ready to get me. Everyone was ready to get me. So 1 minus secant squared x, okay? And that's what we can say is the derivative. You guys cool? All right.
I was waiting for you to finish writing it out, and then I was going to be like, I disagree.
Hey, you gotta give me to the end of the problem, okay? Anytime I forget it, call me out for sure. Maybe I'll bring in cookies, okay, if I forget a label, okay? So f of x equals x times secant x. Now, guys, exactly. I love that you guys are shouting at me product rule. As soon as you see two functions being multiplied together, we have to remember it's the product rule. We can't just take the derivative of x and the derivative of secant x. Okay, we have to use that product rule. So here, f prime x equals derivative of x is just 1 times that second function, right? Plus, well, the derivative of secant x, if I go up and just use these rules, it looks like it's going to be secant x tan x times, what was the first function? Times x. Okay. Now, as I look at this, you could leave it. But notice, here's my first term, here's my second term. Do they have any common factors? Secant x. So here I'm just going to say f prime of x is equal to, I'm going to factor out that secant x. I'm going to be left with 1 plus, don't be too confused, this is technically what I have left, but I don't like writing it like that. I'm going to make that x now a coefficient. So x tangent x. Yay? Yay? Yay for math? Okay. Whoa. All right. All right, guys, and let's look at example 3. And then I do have another example 4. That's a little bit lengthier. So 3, let's say f of x is equal to 1 minus cosine x all over sine x. Why? Because it's glorious. Okay. I didn't do this. Calculus did this. Now, guys, there's a couple of ways we could do this. We could use what rule? We could use quotient rule, or we could be a little bit smarter. Okay, why is that a little bit smarter? Because what does this turn into? That's cosecant, right? And this is cotangent. And now, since I have both of these, what could you do? Find the derivative of each of them separately because they're separated by a subtraction sign, right? So, now if I want f prime of x, there's my label, okay? What's the derivative of cosecant x? Well, I'm just going to look up top. What is it? You got it. Negative cosecant x. Oops. Cotangent x. Okay. Minus. What's the derivative of cotangent? Now, the question is, as I look at, now be careful. You can go ahead and make that a positive sign right now if you want, help you understand it a little bit better. Here, do they have any common, like, terms? Or common factors, sorry. Cosecant x. Okay, so they have a common cosecant x, which means when I factor that out, I'm going to get negative cotangent x plus cosecant x, and there's your derivative. Okay? So guys, notice how this one trick made that okay. One thing I will tell you though, I will see you guys do this, and this is completely wrong. You have to understand how fractions work. If you have like this, you are not allowed to do this. This is illegal, okay? What you guys need to understand is this denominator is tied together, okay? So this is bad math.
Bad math.
Bad math. And if you're wondering why that doesn't work, I just want you guys to even think about two numbers, for instance. What are two numbers I could put down here?
1 and 2.
Okay, what? Yeah. What, it doesn't matter. It'll work either way. So I'm going to choose 7 up top, 1 and 2 on bottom, right?
Yeah.
So we understand this should be 7/3, right? But if we separated it, it would be 7 over 1 plus 7 over 2. This turns into 7. This turns into 3/2, 10.5. No way in the world is 10.5 equivalent to 7/3. Do you see why you can't separate a denominator? It's completely different than what's happening over here. Because here, you're still dividing your numerator by sine x and cosine by sine x. All right? Okay. So here's the last problem, and then I'm going to let you guys discover the chain rule. Discover, yes. You guys are going to discover the chain rule. All right. So here you go. Evaluate the derivative at the given point. Okay? Evaluate the derivative at the given point. So guys, evaluate is a fancy way of saying what? Solve.
Never mind.
No, evaluate is solve.
Wait for this one.
No, you're right. But derivative in this case does mean slope, right? So technically we're finding the slope at this point. You're right. F of x equals sine x times tangent x. The point is pi over 3, comma, 3 over 2. And you can take my word for it that this point actually is in here. I promise it is. Like if I plugged in pi over 3 for sine, I would get 1/2. If I plugged in pi over 3 right here, you know, it would work. I promise. Okay? So. All right. So, tell me, looking at this function, is there any sort of rule I have to use, or can I just take straight derivatives? You have to use product rule. The reason I have to use product rule is because I'm multiplying, right? So as I go through, f prime of x equals, well, the derivative of sine is cosine x times tangent x, right? Plus, because that's what product rule says, I'm supposed to be adding, what's the derivative of tangent x? Secant squared x times sine x. Now guys, this is ugly, right? But who cares? What are we doing? We're plugging in pi over 3, right? So let's just plug in pi over 3 to every x we see. Okay, that's all we're going to be doing. Now we understand why those trig quizzes were so important.
I've taken one and I failed it.
On the positive side, okay? And guys, you will see me when I am squaring a trig function, this is the way I like to write it. If you prefer writing with parentheses around your entire trig and then squaring it, that's fine as well. Okay? All right, as I look at this, now let's just take this piece by piece. Cosine of pi over 3 is 1 over 2. Tangent of pi over 3. Ooh. Yay!
Radical 3.
2 over radical 3.
Sure.
Okay, so let's look at this. Tangent is equal to what? Sine over cosine of pi.
Pi over 3. It's just radical 3.
This is radical.
Okay, so as I do this, just to kind of understand, right here, so sine of pi over 3 is radical 3 over 2. This is 1/2. Therefore, my 2's cancel. I get radical 3 over 1. So tangent is just no pi over 3, honey. Just radical 3. It's okay.
How did you pass through trig?
I don't know. I really don't know.
Okay. Secant squared of pi over 3. So what's secant of pi over 3? Well, secant is equivalent to 1 over cosine pi over 3. Guys, we've already found cosine how many times? Like twice now. So 1 over 1/2, aka 2. But be careful. 2 squared. Okay? And then sine of pi over 3, again, we already did that up here. Radical 3 over 2. Okay? Now let's go through, let's simplify a little bit. This is radical 3 over 2 plus, this is going to be 4 divided by 2. I'm going to get 2 radical 3. You can leave that as your answer. Okay? You are done. If you really wanted to be ambitious and go through and simplify, you could by getting a common denominator of 2. You don't want to, and that's fine. Okay? Does anyone have any questions on the math that I just did? No? All right. So we are done. Okay, we are done with that.